Good morning. I'm here to convince you that data science is a great thing to work on. And basically, I'll try to give you some hints on what we mean by data science, then tell you why data science is important nowadays, and then wrap up with a few examples or illustrations on things that you can do with data science, okay? So first question, what we mean by data science? So essentially, if we go and to the usual sources to search for knowledge, then Wikipedia will tell you that data science is essentially the extraction of knowledge from data. Actually, if you are willing to read a bit more, then you get a much more extensive definition, and I'll go on purpose by reading these long lines of texts that tell you that essentially in data science we employ techniques from mathematics, statistics, information technology, and theory. And then we include things like signal processing, probability models, machine learning, statistical learning, data mining, database, data engineering, pattern recognition, learning, visualization, predictive analytics, and so on and so forth. I'm already tired, so you see it's a big list. So it's something which is a bit uncomfortable to ask someone to be a specialist on all these topics, okay? But then it's supposed to be, because after all, data science is supposed to be the sexiest job in the 21st century. So according to Harvard's Business Review, so it better be hard to be a data science. So that's the reason for this big list of things that you need to know. And the reason for that, or one of the reasons for that, is the fact that according to McKinsey Global Institute, roughly in 2018, only the US will face a shortage of roughly from 150,000 to 200,000 people with this sort of abilities. And moreover, roughly 1.5 million managers should have also this sort of knowledge, okay? So be able to handle the large sizes of data. So that's, again, a reason why this is a sexy job or a trendy job, and also a reason why, according to Forbes, training tomorrow data science is supposed to be a very hot job. So now it doesn't come as a surprise if you see me smiling a lot, because that's the two things that I do. So hot and sexy job, so that's why I keep smiling. Okay, so anyway, so data science essentially it's just a buzzword. Okay. So what we do is we analyze data, okay? And actually, data science is a relatively recent buzzword. Before, people would like to talk about business analytics, and before data mining and knowledge discovery. And I bet that sooner or later there will be another buzzword, okay? So, but in the end of the day, essentially, you are talking about analyzing data, okay? But then, is really data science just standard data analysis that exists for so many years, actually centuries? Well, there are a few tweaks, okay? So first of all, there is the issue that we are facing a huge amount of data, okay? So size is the first thing that really distinguishes what we do in data science and what 1 century back people were doing when analyzing data, okay? So size is really a critical issue. Another critical issue is the diversity of data sources, okay? So nowadays we receive data from cameras, from sensors on the sea, on a satellite, wherever, So we have a big diversity of data sources, which again is a challenge to the standard data analysis tools that we have. Then there is also the challenge posed by different data types. So we don't have these, simple flat tables of data. We also have sound, we have images, we have videos. And so we need to be able to somehow extract knowledge from these different sources and different types of data, okay? And so that's essentially some of the main challenges that one faces in nowadays data science or nowadays data analysis, this diversity of sources and types, and also the size, okay? But at the end of the day, there are not so many real data analysis tasks in spite of all these novelties in terms of sources and data types. So in the end, people work a lot on trying to transform these different sources of data and types into some manageable format that then translates into some data mining tasks that exist for so many years, okay? There are new things appearing because of these challenges, but not so many as the different types of sources of data and types, okay? So let's move into the second question. Why is data science important? So I guess from what I said before, there are already good motivations for data science being important, but the reality is that, in effect, we live on a world surrounded by data. So we have data everywhere, and that results from several things. One of them is the fact that we have all sorts of ship sensors available for collecting data in real time everywhere. The sea, on rivers, wherever, sensors are getting cheaper and cheaper and smaller, so it's very easy to collect data on different sorts of environments and organizations. Then we have the issue of, ever-increasing computing power. Nowadays, smartphones are much faster than the computers that I'm afraid I needed to work when I was learning my IT degree. So, computing power is really amazing nowadays. Then network is everywhere. Nowadays, it's very hard to be somewhere where someone doesn't, is not able to bug you with some email. So networking is everywhere. And then another reason is all this fancy topic of the Internet of Things. So everything now is connected and is collecting data from fridge, from cars, wherever. So everything is getting connected, and things are connected together and collecting data of your interaction and their own interaction with each other. So all these sort of things increase for this fact that our world is surrounded by data, and that's the main motivation for being necessary to work on data science, because data really is everywhere, and you are aware as a business manager or whatever that this data somehow hides important knowledge for your organization or for your business. Okay, so that's the main motivation for data science, and why everybody keeps talking about this thing. All right, so so I have here a few case studies instead of keep telling you how to do data science, which would be a big challenge to do in 20 minutes or something. But I have here a few case studies or examples of how to apply data science techniques to solve some problems. But first of all, just to give you a brief flavor of the typical workflow that we follow on data science. So the basic thing, of course, is understand your problem, your business, and then there is, and this is also very related with the previous slides on the different data sources and the different data types. There is a very important step, which is data preprocessing, okay? So this is something that actually, as being also an academic, I'm a bit embarrassed to admit, because this is something that usually you don't teach students, okay? It's not sexy, okay? So that's, data managing, it's small tricks, but actually in the end, that's part of the most important thing on any data mining project, okay? But if you buy, a textbook or something, you see at most a very small chapter on this sort of things, okay? But that's, in the end, roughly 60 to 70% of the time on any data mining project is spent on this thing. So it's very important to be aware that it's an important step. And then, of course, you have all the fancy models that you can do after you manage to put your data into some understandable format by these standard models. And then, of course, there is the important issue of somehow measuring the performance according to your business objectives of these models. And finally, the also demanding deployment of these models. So that's more or less the workflow. Of course, there are many cycles around here, but that's more or less the main steps of any data mining project. And again, as I mentioned, nowadays, most of the stress, because of all of these different data sources, is being put on this part of data preprocessing, okay? And that's where we tend to spend most of our time. Okay, so now I'll talk a bit about some general problems in data science and then give you some specific examples of these general problems, okay? The first one I would like to talk about with you is the general problem of monitoring and forecasting data streams. So data streams essentially are data that flow almost in real time, or sometimes even in real time, measuring some sensors. So you have a set of sensors, and then values flow over time. And these sensors somehow are supposed to reflect the state of some machine or some business or wherever. And what you want is to, first of all, you may want to monitor these sensors for detecting abrupt or abnormal changes on these values. You may want to forecast the future evolution of these data streams. And then you may eventually want to anticipate critical states of the system. So suppose that the state of the system depends on all these parameters that flow over time, and you want to anticipate that with these trends, then we'll have, you know, a serial failure or whatever, okay? So that's typical things that you want to do with this sort of data, okay? Now, some concrete examples of this or instances of this general problem. The first one is a project that we had actually here with the company that runs or manages the water distribution network within all this metropolitan area of Porto. And so what they have, you know, it's a series of tubes that takes, you know, water to your homes. And of course, there are lots of water quality parameters that you need to make sure that they obey some legal limits, because of course you don't want to poison people with the water. So there are many parameters that are regularly sampled on different points of this huge network, huge water distribution network, okay? So the data somehow fits this model of having actually literally hundreds of water quality parameters being measured over time on different points of time, but also, and that's a slight variation on the general problem, on different times, on different points of space, because there is, you know, some geography here involved also, okay? So that's not only time, but also space involved here. So we kind of develop a series of tools and models that, first of all, allow managers to visualize all these hundreds of parameters evolving over time, because it's important to be able to grasp what is happening with this, all these numbers. And actually, you've seen on the previous talk, you know, these dashboards with all these time series flowing over time. It's important to have nice visual tools to allow people to inspect what is happening to the system. Also, some tools for monitoring anomalies, or actually what is really relevant for them is to anticipate these anomalies, okay? Because you don't want to find out that your water is very bad. You want to anticipate that this is going to happen so that you can take preventive actions, okay? And that is also, because this is a very complex system, because there are lots of things having impact that you don't control, having impact on the water quality, even if the water is within pipes. Because, you know, workers spoil stuff, you know, pipes break. There are lots of things happening that you cannot control, okay? And so one of the things that they wanted was for us to establish what are the limits of normality for each of these water quality parameters, okay? And these limits should be tighter than the legal limits, because if we overcome the legal limits, then they pay heavy fines, okay? But they should not be so tight that we keep firing alarms, because then they need to send a team there, check, and that's money, okay? So we want to play with these limits, and these limits need to be dynamic, because this is a complex system. You know, water in the summer is not the same thing as water in winter, okay? So that there are lots of seasonality effects here. So we develop a series of tools that allow us to check for instance, the quality of the water along the pipes, because it's not the same thing, the quality when they get out of the treatment station and at the end of the pipe. It's not the same thing, okay? Things change over the space of this system, okay? So that's one example. I know other examples, for instance, are on sports analytics. lots of statistics and measurements are being taken in real time, typically on a game, during the game or prior to the games. And again, we have this property of having time series flowing over time with some aspect which is important within the game. And then there are some states that depend on these things. For instance, winning or losing a game, okay? And of course, the sooner you are able to anticipate that this trend on these statistics will lead to a loss or a win, then probably you want to inform managers so that they can take preventive actions or do something to try to change these trends, okay? So there are also some nice applications on this area, which again are instances of the general problem of having data streams that somehow reflect the state of a system, okay? And so the idea here typically is to anticipate the final state or result of the game, but there are other hypotheses also for playing with this data. Okay, so the solutions typically that we follow here is, first of all, of course, we assume that the future state of the system somehow depends on the current state of this machine or whatever that you are inspecting. And our goal, in a way, is to, based on this assumption, is to construct a data set where we, giving our historical record of, available for this system, we want to map states into what happened next, okay? So we have an historical record where we see, well, when this was happening, then that happened, okay? And so we have a huge data set with this kind of history of what happened on this machine or on this game or whatever. And then once we are at this stage, of course, we can apply all our nice tools from predictive analytics to try to anticipate or to try to map the current state into some highly probable future state. Of course, the main challenge here is how to describe the current state. The basic thing would be just to look at the scores of these different statistics, for instance, and that's it. But that's very simplistic because there is some time correlation. Of course, maybe you should look to the tendency of these streams. You need to be creative here to try to manage to represent what is the current state in terms of these streams of your machine or wherever you are studying, okay? So that's the main challenge here, how to transform these data streams into something that reflects what is the current state of the machine. So that then you can use your nice tools to try to forecast what is the most probable future state of your game or whatever, okay? So some possible paths here is not using only the last values, but using some recent values. Of course, we want to put more weight to the most recent observations, but there are other things that you can do. You can try to aggregate all these values into some measurements or indicators of trends or variability and so on and so forth. So there are many things that you can do, but again, data preprocessing, okay? So that's the big issue here is, again, data preprocessing. You have all these sensors, and you want to transform them somehow into some flat table that you can apply your nice tools that you have on predictive analytics, okay? So the big push here is on this issue of how to describe the current state. Okay, so next kind of general problem that we tend to face nowadays a lot in data science is handling text data. So text data basically consists of documents written on some language or eventually different languages, because you can have sources that contain documents in different languages. And these may be plain text files, blog entries, emails, whatever, and that's your source data. So very different from these time series that we've seen before. So with this, typical goals are first, try to identify which topics are being addressed on a text document. Classify documents. For instance, is this spam? Is this not spam? Okay. Dictate sentiment on opinion. Okay, so I know the topics being addressed, but are the people happy with this? Are they very positive of this topic? Or what is the sentiment or their opinion on this thing? Summarize documents. Nowadays, we don't have time to read all the stuff. Okay, so if we have a nice tool that summarizes the key ideas, the most important ideas on some text document, that's important. Actually, we have currently a project starting with some English company that their goal is exactly that one. Their target is that people can input a URL with some news, and then we just provide a rank of the main topics, the main sentences on this document. Okay, so that's text summarization being already used on sold to clients. Okay, so and there are many others, but these are some things that you can do with text data. So again, some concrete examples. The first one is an European project that we have participated that had as well. It was a very ambitious project that had as main goal to help policymakers. It's a pity that the mayor is not here anymore because I could sell him the tool. But anyway, the idea is that policymakers need to make decisions, okay, of course. And there are several things that they need to take into consideration. Sorry about the picture, doesn't look very nice. But there are things like financial constraints. And the case study for this project was actually energy policies, okay? So there are other things like the impact on the environment, incentives that you can give to the population, for instance, to put solar panels and so on and so forth. So there are many things that the policymaker can tweak, and these things will have an impact on how people react to these, in this case, energy policies. And so the project essentially tried to provide tools to optimize the solutions, to use things from game theory and social simulation to actually simulate future, what would happen if I did something without having really to do that. But also it had a part on opinion, because it's very important also for policymakers to know what people think about the different policies, okay? And particularly in energy policies, it's very, very important. So that's the part where we enter, and the main objective was to try to infer what is the sentiment of the population regarding a set of topics which were relevant for these policymakers within the energy field, okay? And so, moreover, we also wanted to know how this sentiment evolved a long time, because, people make decisions, so I want to know what was the impact, if any, of this decision in terms of some of the topics related to energies, okay? So that was our task. So as source data, the Emilia-Romagna region in Italy, which was the target, had several e-participation portals and blogs and so on and so forth that they kind of provided to the population so that they could participate and said what was their opinion regards several topics on energy policies. And so that was our source data. So we had crawlers going over these infrastructures or these portals to grab new posts from people, and then we were trying to automatically infer the sentiment on each of these entries, and so that we could provide this to the policymaker. So I'm going to try to make a short demo if the network collaborates with me. So let's see. Okay. Yeah. Okay, so this is a short demo. Actually, it's developed by Fraunhofer. So it's running in Germany. So let's hope this. So basically, what you have here is the overall picture in terms of the energy, the things that interest the policymaker regards the energy topic. So I'm going just to show you the part on opinion mining, which was what I was talking about. So essentially, you can go here, and then you can, whoa, this cuts some part. But anyway, you have here a series of topics that are of interest to this energy policy. And so the policymaker can come here and select one of these topics. And then what we'll see is each of these dots are, whoa. It doesn't show the bottom graph very well, but anyway, there are some gray bands on these lines showing the kind of deviation. But what it shows is for each individual post, each dot is an individual post, and then you have here a scale of sentiment from very positive to very negative. And here you have a kind of aggregation, currently is monthly aggregation. And so what this allows the policymaker is to know the tendency of the public opinion regards some topic. And you can click on more than one topic and see the evolution. And then you can actually then drill down. So if you are curious about some of these topics, you can drill down and then it will fetch if the network allows. So it should be, I'm sorry about that, but there should be appearing here actually direct links to the posts, and so the policymaker can actually click them and read what the person was saying about this topic. Okay, so that's more or less the idea. Okay, so let's go back to this. The other thing that we have been doing with text data is news recommendation. So nowadays, if some user has some question about some topic and wants to know what are the good news about this topic, let's say, financial crisis, whatever. So there are a few official media, let's say, like Google News, Dig, Feedly, and so on and so forth, that can provide you a kind of ranking of suggested news regards this topic, okay? So what we are doing now is we are trying to contrast these kind of official recommendations with what people on their social networks think it's really important for this topic, okay? So people read these things and then if they like, they suggest, well, look, read this news because this is really very interesting. So we are trying to somehow aggregate the community opinion regards news and what the official media is recommending you to read, okay? And so we are trying to provide this kind of a news recommendation ranking, which is social influenced by what people really deem as important to read on some topic, and then feedback this to the final user, okay? So that's another example of using text data. Okay, so again, the main challenge here is how to move from text to, again, this simple flat table where we can apply all our fancy models. So again, data preprocessing, okay? And so there are many approaches around. Some of them, like the bag of words, are really very simple, and they seem stupid because, when you look at the text, you see semantics, you see order of words, and this bag of words basically counts the number of occurrences of words, okay? There are some other things going around, but essentially you lose all the structure, all the order of the words. So it seems very stupid to do that, but actually it's one of very easy to implement and very efficient way of handling or transforming text into something which is manageable. But there are many other things which are slightly more complex, and I'll just leave you here with some terms. Okay, so last one, anomaly detection. So it's again a big application area. And essentially here we have data describing past transactions, and these can be different setups, as you will see. And then eventually we also have information of some of these transactions or cases having been audited by some team of our organization. And eventually we have the outcome or the results of these auditing activities, okay? And so now the typical goals are to identify strange situations on new transactions, I don't know, frauds, errors, attacks on some network, and so on, and also to provide auditing support, okay? So you have a team, this team has limited resources, you want to direct their resources to the cases that really matter, okay? So you want to provide a kind of ranking of inspection or audition, okay? And that, of course, the goal is to maximize the return of these auditing activities, okay? So let's see some concrete example. The first one is on attacks to computer networks. Here, typically, the data that we have is network logs or network traffic logs. And here, normally, we want to identify attacks as soon as possible, okay? So here, again, I'm going to try to give you a demo. This is not my work, but it's actually so nice that I wanted to show it too. Let's see if the network shows you something. So what you'll see here is really in real time, and this is really real time, hopefully. You'll see a representation. Come on, network. Where is, oh, stop your mobiles, you know, I need some bandwidth here. But what you would see here was a map, a representation of the world, and then you see, like in a game, you see shots from different countries to different countries going on, okay? And then over here you'll see the actual IPs, the origins, the sources of attacks, and the targets of the attacks, and then you'll see everything moving very fast, as you can imagine. And then you'll see here another thing, which is already an effect of data science. You'll see for each attack the type of attack. So there is also some intelligence here going on to identify this is an attack and it is of this sort, okay? So that would be the nice demo, okay? Sorry about that. Well, it's not my fault, but anyway. That's one instance of this fraud detection. Another one is, for instance, identify fraudulent transactions, for instance, in tax evasion, telecommunications, credit card transactions, and all these sort of things. And again, here, the data is typically transaction reports, and eventually we may have information from past auditing activities, okay? And so now, again, our goal is to give a new transactions, either to classify them into valid or fraudulent, or eventually provide auditing ranks, and of course, with the goal of maximizing our return, okay? So the key issue on all these applications is what is a deviation from normality? And that's a tricky question because, you know, people that do attacks and frauds actually try to disguise their activity as normal. So, you know, they are not going to play nicely with you, with your models, okay? So that's a difficult thing to do. So typically, people tend to use statistical notions of outliers and so on, but we have recently come up with the concept importing some ideas from the theory of utility from economics, the idea of utility-based fraud detection, where we try to incorporate the statistical notion of the probability of outlier with also some estimate of the expected return of your audition and also the expected cost of the audition activity. And so we come up with some nice formula that integrate these three concepts and then provide you a kind of utility-based score of inspection, okay? So, because sometimes something which is clearly a fraud, it's not worthwhile, your resources, okay? Maybe you have another case which is not so convincing, but then if it is confirmed, then it's a big return for your company, okay? So that's important to take these things into account. Okay, that's the end. I hope you had, you know, apart from these slight deviations of the plan, you have some fun and you are convinced of the importance of data science. So thank you for your attention, okay?